So let's see if you remember. What is the difference in a polynomial and a quadratic? A quadratic, well, the degree is 2 on a quadratic, and a polynomial can have any degree, right? So a quadratic is a polynomial, but a polynomial is not always a quadratic, right? Because poly just means, in our case, one or more. It can be, a monomial is a polynomial. All right, so we're going to talk about factoring these polynomials, which can get big or small, and we're going to work through, this is an assumed, I've never really agreed with it a whole lot, but technically this is something that's taught in Algebra 1, factoring polynomials. If you've never seen it before, that is okay. I don't expect you to have seen it before. I've never gotten this far with my Algebra 1, so assume you haven't. All right, so the first thing we're going to talk about is how to take out a GCF. What does GCF mean? Greatest common factor. You guys should be very familiar with that. Greatest common factor. And that is our most basic way of factoring, is we take something out they all share and we put it on the outside, right? We backwards distribute it. So look at number 1 there. 12a cubed plus 10a squared. If I wanted to find the greatest common factor there, what would it be? 2a to the second. And if I want to actually take that out, I put it on the outside, and what's left inside? Plus 5. That's exactly right. The goal is that when you distribute it back through, you end up with what you started with. Does that make sense to everybody? Pretty good on GCF. We've spent a long time on that, so you should be good. I'm going to leave number 2 for you for your homework. The next one is a difference of 2 squares, and we have talked about this. We haven't talked about the pattern quite as much as you could still do it the old-fashioned grouping way. Difference of 2 squares. So a couple of things here. First of all, this only works when I've got a difference. What does yeah? Huh? You can get a packet? I didn't put them on y'all's desk. All right, what does difference mean? Subtraction. So this only works if you have 2 perfect squares separated by a subtraction sign. So over there on the side, you have a squared minus b squared. They're both perfect squares. There's a minus in the middle. How does that factor? Do you remember? A minus b, close, a plus b. Different than that perfect square trinomial, which that's the way it factors. This one, you do the square root of the ends, and you do 1 minus and 1 plus. So look at number 3. 9x squared minus, and this is, again, getting your feet kind of wet to factoring again. They're laid out by difference of 2 squares. They're not just all jumbled together and you have to know what to do. So here, I know this is a difference of 2 squares. They're both perfect squares. Do you agree? What does it mean to be a perfect square? Multiply itself twice and you get that number, right? So what times itself twice to give you 9x squared? I was fixing to say it. 3x, right? And what do you multiply by itself to get 49y squared? 7y. I do one with a subtraction and one with an addition, and that is factored. Everybody okay? These are just special patterns that we talk about that make factoring easy. Let's do number 5 together. Now 5 is listed under difference of 2 squares, but these do not look like perfect squares at all to me. What in the world do I do? Do what? No like terms yet. Say again. What is that called? We got to find the GCF. That's always my first step in factoring. Very good, though. I'm looking for a GCF that I can take out of everything first. That's always my first step. So I did hear 7. Is there anything more that I could take out of both of them? M and N. That's exactly right. If I take out an M and I take out an N, what's left? M6, that's exactly right, minus 4 Can I do anything else? Tell me what it means one more time to be a perfect square. Something times itself gives you that value. So is there something times itself that gives me m to the 6, and something times itself that gives me the 4n? 2n on the bottom, you're exactly right. How about up top? How about that m6? I see no. Let me ask you this. What does that equal? Why? You add the exponents. So actually, m to the 6 is a perfect square. In fact, if it's an even exponent, it is a perfect square. So now finish factoring this. We've got the 7mn outside. What's it look like factored? What goes in the first spot? What times itself twice gives you m to the 6? M to the 3rd. What times itself twice gives you 4n squared? 2n. I do 1 minus and 1 plus. Okay? So now instead of it just being quadratics that we're looking for a difference of 2 squares, it could be these polynomials that have these higher degrees, right? Y'all okay there? You need me to do another one? Another one? I was going to say 4 or 6. We'll do 4. Number 4. 72c to the 4th power minus 2. What do I look for first? Greatest common factor. 2. If I take that out, what am I left with? Oh, I recognize 36 being something special. 36c to the 4th. Did I just stop there? Minus 1. That's exactly right. Remember, whenever you go back and distribute, you have to have what you started with. Okay. Can I do anything else? Yes. This is what? Both of them are perfect squares. What do you multiply by itself to get 36c to the 4th? Look at y'all. 6c squared. What do you multiply by itself to get 1? 1, right? So I have 2 times 6c squared minus 1, 6c squared. All right, y'all ready for the new stuff? Oh, that's a good question. I have the sum, and I always teach sum and difference of 2 cubes together. But the first question is, what is a perfect cube? Any guesses? You're exactly right. Y'all are exactly right. Times itself 3 times instead of twice. So is 27 a perfect cube? What times itself 3 times would give you 27? 3. So yes, 27 is. You said 8? Yes, what times itself 3 times gives you 8? 2. What are some other perfect cubes? Give me another one. 125. What times itself 3 times gives you 125? Do I know any others? Let me give you a list of ones that I would need you to be able to recognize, at least through 6. So 1 to the third is obviously 1. 2 to the third is 8. 3 to the third is 27. 4 to the third, 4 times 4 is 16. Times 4 is 64. We said 5 times 5 times 5 is 125. And then 6 times 6 is 36. Yep. And 36 times 6 is 216. Go a little bit further. 7 times 7 is 49. Times 7 again is 3. So this is 1 to the third, 2 to the third, 3 to the third, just so you remember. Now, keep this in mind as we look at these, okay? Because I'm still looking for things multiplied instead of 2 times by themselves, 3 times by itself. So we've got this sum and difference of 2 cubes. So I've got something to the third power plus something to the third power, or I've got something to the third power minus something to the third power. And I do these together, and I think you'll see why. This is a straight up memorization. Like, you just have to memorize it. There's no easy way to do it. So here's how I do it. I set up a little parenthesis and a big parenthesis. What was what? Okay. I always do the signs first. The signs are going to be the same sign you started with. So for the sum, it would be what? What sign's in the middle? Plus. For the difference, it would be minus. Change it for the second sign here. The same change. So this one would be what? Minus. And this one would be plus. And your last sign every single time is always plus no matter what. Same change plus. You may have seen it, especially if your teacher put you on Alex or anything, you probably saw it. I'm not an Alex fan. My daughter was in there in 8th grade, and it was. This gives you a to the third. Oh, I'm sorry, I haven't even told you what the pattern is. All right, so in these first 2 spots, I put my a and my b. Okay, so in other words, what times itself 3 times gives you a to the third? It's just a, and it's just b. Okay? These are the same for both of them. That's why I do this together. Now, here's the confusing part, because it starts to look a lot like a perfect square trinomial, but it's not. You square the first one for the first spot, and you square the last one for the last spot. And in the middle, you multiply these 2 together. Don't double it. It's not multiplied and doubled. It's just multiplied. And the pattern is exactly the same over here. I realize that the variable form of this is a little intimidating as you look at it. So let's do an example that's going to help you a little bit more. Notice this can be sum or difference, but these perfect squares can only be difference. Well, let's just do number 7. Y'all have that? Okay, I'm sorry. I kind of wrote it, they go in 2 different places on your paper, but Ready? All right, let's do 7. No GCF here, right? What do you notice about those two numbers then? 27 is a perfect cube, as is x to the third, right? X times x times x is x to the third, and 3 times 3 times 3 is 27. So here's what I do. I'm going to set up my parentheses first. Little parenthesis, and then big parentheses. I've got a binomial times a trinomial. What signs are going to go in here? That's exactly right. Plus, minus, plus. Same change, plus. Same change, plus. All right. Fill in your first parenthesis first. What times itself 3 times gives you x cubed? And what times itself 3 times gives you 27? I don't even need the problem written in black now. I can just use the green to form my next one. So square the first and put it in the first spot. Square the last and put it in the last spot. And multiply them together for the middle. Is that too terrible? Of course it's going to get... Write what down? So this is the first squared. It comes from here. Last squared. It comes from here. And then this middle term is the 2 multiplied together. Let's look at another one. Let's do 13. No, let's do, no. Let's do 13. Yeah? Which one? 10? Remember, my first step is to look for a GCF, right? Do you see a GCF? You might have to take out your calculator for this one. Do you see a GCF? Can I divide 24 and 375 by anything? 3? How about C and D? I can take out a 1C and 1D. Do you agree? All right, so what's left? If I divide 24 by 3, I get 8 C cubed, that's right, plus what's 375 divided by 3? 125. Oh, I'm seeing some familiar numbers. Now what do you see? I see 2 perfect cubes. That's exactly right. I know what you meant there. The 3CD stays on the outside. Set up your parentheses first, little and then big. What do my signs inside here look like? Plus, minus, plus. As long as they're both perfect cubes, you always do same change plus. What times itself 3 times gives you 8C cubed? 2C. What times itself 3 times gives you 125D cubed? 5D. Now be careful because these both have coefficients on them. The first one squared, what is 2C to the second power? There you go. 4c squared. Last one for the last spot would be what? And how about the middle? That's exactly right. I'm going to stop with sum and difference of two cubes, but I'm going to do a difference one with you too. Let's do 13. You think it's hard? Search said it's hard.
Good morning, Camden High School. This is Senior Class President Olivia Spivey here with the morning announcement.
4. What's left when you take out a 4? That's exactly right. I have a no, because now that's yeah, the transfer from number 10. Yep. This is really find the pattern and plug and show. That's it. All right, I've got a difference of two cubes. 1 times 1 times 1 is 1, and 2h times 2h times 2h is 8h squared. So set up your parentheses, little parenthesis, big parenthesis. What times itself 3 times gives you 1? Oh, I forgot my signs. Same. What goes in the second slot? 2h. Now you tell me how the trinomial goes. Which is 1. So you're good, that's fine, keep going. 4h squared, that's right. What do you do in the middle? 2h. Ignore the signs, because you already took care of signs when you did same change plus. So just smush them together, multiply them together. All right, so tonight what I want you to do is finish 1 through 14 on the first page. And then 1 through 12 on the next. Okay? Be careful and watch out for things whenever you have to start looking at difference of two squares and difference of two cubes, okay?